Good day to all. The DOST GIA-funded project entitled Utilization of Spent Tea leaf in Tobacco Dust as Additive for Plywood Adhesives was conceptualized by the project team to utilize the untapped potential of these two voluminous industrial and agricultural solid waste as potential replacement for the traditional glue mix additives used in plywood manufacture. The project team was composed of specialists from chemistry, entomology, economics, and wood-based composite panels. Any wood-based panels bonded by formaldehyde-based adhesives can emit formaldehyde gas due to presence of free formaldehyde, which can escape from the panels. This formaldehyde gas, based on studies of the World Health Organization, is carcinogenic and may possibly accumulate in the body through prolonged inhalation or exposure to it. Hence, formaldehyde emission from wood-based panels is regulated by various countries such as USA, Europe, Japan, Australia, and New Zealand. In the Philippines, formaldehyde emission was recently became a mandatory test that need to be passed by plywood manufacturers. On the other hand, one major disadvantage of using plywood as housing components is its susceptibility to termites. There are two types of termites that may attack wood-based structures. One is the drywood termites, and another is the subterranean termites. Both termites are destructive. However, between the two, the subterranean termites is easily detected due to presence of visible mud tunnels, while drywood termites is initially undetected as it does not make tunnel and may be detected only when fecal pellets is found at the base of the wall, floor, or corners of the wood-based products such as cabinets, tables, or plywood partition walls. As a potential solution to these two major problems, wood-based panels, we studied the use of spent tea leaves, an industrial solid waste from making of tea flavored drinks and waste tobacco stalks after harvesting of the leaves, as an alternative glue mix additives in lieu of traditional extender with flour and filler, rice hull, or coconut shell flour. We processed the alternative glue mix additives to produce powder of flour-like texture. Because of the presence of rich polyphenolic substance and protein in the spent tea leaves, it was hypothesized to scavenge free formaldehyde in the wood-based panels. On the other hand, waste tobacco stalks contain alkaloids such as nicotine that can act as repellent substance against termites. The potential impact in the industry and community are the following. For the spent tea leaves, utilization of about 18 tons wet basis daily waste can significantly reduce solid waste disposal by adding value to this material. For the waste tobacco stalks, about 900 kilogram tobacco stalks per hectare can have additional value which may potentially add income to the tobacco farmers. For the plywood producers, the reduction in formaldehyde emission may help pass the stringent requirements of the PNS ISO standards. For the plywood consumers, service life of plywood may be extended, hence break and replacement due to damages caused by termites may be avoided. Also, there will be better air quality in enclosed rooms due to lesser formaldehyde gas emissions. For the project journey, we formulated several glue mixes both for the urea formaldehyde and phenol formaldehyde adhesive. We tested their pH and viscosity to determine which glue mix can proceed to experimental plywood making. Using the laboratory facilities of FPRDI and veneers obtained from the plywood industry, we made several experimental plywood from the glue mixes that passed the pH and viscosity requirements. We tested the experimental plywood for their bond strength, formaldehyde emission, and the resistance against the drywood and subterranean termites. We use ISO standards adopted by the DTI BPS as PNS ISO standards to determine the bond strength of the experimental plywood. The same with the formaldehyde emission, we use the PNS ISO standard and established PNS limits for the formaldehyde emission. Based on tests conducted, the best glue mix formulations developed with acceptable plywood properties were piloted to produce full-size plywood in 2 factories. We obtained the pH and viscosity for comparison to our laboratory data. The pilot-produced plywood were tested in actual construction in partnership with a construction company, and a house owner operator to determine the workability and performance of the produced plywood. The pilot produced plywood will be observed for 5 years to determine its thermite performance in service, as well as the bond integrity, especially the plywood used for sealing. We are calling on the concerned national government agency and the private industries to collaborate to produce the alternative additives for the use of the plywood industry. The missing link to commercialize this technology is the company which will produce the alternative glue mix additives. For further inquiries, you may connect with us by visiting the FPRD website and contact us through our telephone numbers or by emailing us. Thank you.